This is section 11.3, geometric sequences. Yesterday we looked at arithmetic sequences and learned a formula. Today we're going to do geometric sequences. With an arithmetic sequence, you had a common difference. With a geometric sequence, you have a common ratio. How do we find the formula for the nth term of a geometric sequence? How do we find specific terms of a geometric sequence? If our sequence is 5, 10, 20, 40, and 80, you will notice that this is a geometric sequence, not just because we're in the geometric sequence lecture. So you will notice that there's a ratio of times 2. Every term is the previous term multiplied by 2. You can see that 40 is the fourth term, T4, and there have been 3 ratios of 2 applied since T1. T5 is 80, and that's after the fourth ratio of times 2. So you will notice that there is a difference between T5 and T1, 4 times 2. How many ratios of 2 will there be for T10? From T1, you will multiply by 2 9 times. 9 times. So, 10 minus 1, the difference is 9. And that's how many ratios you're going to apply. What if we want to find a formula? We apply 9 ratios. So, if you want to express that, you would take the first term, 5, times the ratio, times 10 minus 1, because that represents the difference in terms. That comes out to 2,560. For t sub n, you would apply the ratio n minus 1 times and multiply it to the first term. So you see where this formula that we're going to show on the next slide comes from. You're going to have a common ratio. You're going to multiply it by the first term n minus 1 times. And our formula is this. In a geometric sequence with first term t1 and common ratio r, the nth or general term is given by this formula. Tn equals t1 times r to the n minus 1 power. The nth term is equal to the first term times the ratio to the n minus 1 power. And this is one of the equations you're going to have to memorize. But if you forget how to memorize it, just try to reconstruct a geometric sequence and you can come up with the formula on your own. Example 1. Find the formula for the nth term of the geometric sequence. We have 81, 54, 36, and 24. So the first thing we're going to need to do is figure out what the ratio is. So to find a ratio, just take the second term divided by the first term. And if you take the third term divided by the second, that's fine too. But let's keep it simple. So we take 54 divided by 81, which reduces to 2/3. That is our ratio. Now, we know what T1 is because we see it. It's 81. All you do now is plug them into this formula and find the formula for Tn. And your answer is 81 times the ratio 2/3 to the n minus 1 power. So, for the nth term of this sequence, you take the first term, which you know, multiply by the ratio to the n minus 1 power. You have to calculate the ratio by taking one term and dividing it by the previous term. Example 2. Now we have a sequence of 2, -2, 2, and -2. Again, you're told it's a geometric sequence, so we know there's a common ratio. What is it? Take one term divided by the previous term. We'll take term 2 divided by term 1. And you see the ratio is -1. We know that the first term is 2, so again, you just plug them into the formula. And you see that our equation is 2 to the -1, 2 times -1 to the n minus 1 power. And you're going to see this -1 or a negative sign in a lot of these geometric sequences. When you see a negative as a ratio, the sign is going to change from one term to the next. And it's always going to alternate. Example 3. Find the specified term of the geometric sequence. 3, -6, 12, -24. So we're looking for the 10th term. What is r? Again, take one term divided by the term immediately before it. So we'll take the second term divided by the first. -6 divided by 3 gets you a ratio of -2. First term is 3, so let's plug them into the formula. So we know the nth term goes by this formula. 3 times -2 to the n minus 1 power. Now, since we're looking for the 10th term, let's plug in 10 for n. And so the 10th term is equal to 3 times -2 to the 10 minus 1 power, which is -512. Therefore, the 10th term is -1536. So, to find a specific term, get the formula for the nth term, then plug in a value for n and solve the equation, or just simplify the expression. Example 4. Find the specified term of the geometric sequence 15, 3.6, and so on. We are looking for the 7th term. So, again, try to do this on your own. You know the steps by now. Solve for the 7th term. Alright, r. r is found by taking one term dividing by the term before it. So 3 over 15, and our r is 0.2 or 1/5. Our first term is 15. Plug them into the formula. So 15 times the ratio 0.2 to the n minus 1 power. Now let's take 7 for n, plug it in. So T7 is 15 times 0.2 to the what's going to be 6th power, which is this small number. Simplified again, and your 7th term of this sequence is 0.00096. So again, figure out what r is. You know the first term, plug them into the equation, and find the 7th term. Example 5. Find the specified term of the geometric sequence. We are now given that the second term is 6 and the 5th term is 750. So we don't have the first term. We don't have the ratio because we don't have successive terms. How do we do this? Well, write down equations for T2 and T5 in terms of T1 and the ratio. So for T2, 6 is equal to T1 times r to the first power because 1 is 2 minus 1. For T5, 750 is the first term times r to the 5 minus 1 power, or 4. Now what you can do is solve for T1. T1 is going to be 6 divided by r, by dividing both sides here by r. And now substitute that value for T1 into the second equation. So you get 750 equals 6 over r times r to the 4th, which simplifies to 6r cubed. So divide both sides by 6, and r cubed is 125. So r has to be 5. So now we know that r is 5. We also can figure out the first term because the first term was 6 over r, so it's 6/5. Now that we have an r, we have T1, we can now find the formula for the nth term and therefore find the 7th term. So 7th term is 6/5, the first term, times the ratio to the 7 minus 1 power, 5 to the 6th. So you get 6 over 5 times 15,625, or 18,750. So when you're not given the first term of the ratio, but you're given two terms in the sequence, write down two equations, solve for the ratio, figure out the first term, plug them into the formula for the nth term of a geometric sequence, and solve for the nth term, in this case the 7th term. Find the specified term of the geometric sequence in example 6, k squared, k to the 5th, k to the 8th, all the way, and so on, and we want the 20th term. So, now that you know the first term and the ratio, we can figure that out. The ratio, take one term divided by the previous term, k to the 5th divided by k squared, which reduces to k cubed. Again, you know the first term is k squared, so let's write our nth formula. Tn equals k squared times k cubed to the n minus 1 power. Now that you have an exponent of an exponent, you can multiply those. Tn is k squared times k to the 3n minus 3. Now, you're multiplying two exponents with the same base. You can add the exponents together. So, 2 plus 3n minus 3 gets you k to the 3n minus 1 power. So, essentially what you have an arithmetic sequence as the exponent, and that becomes a geometric sequence for the sequence as a whole. So let's find the 20th term, plug in 20 for n, and you get T20 equals k to the 59th power. So this is no different than some of the questions like examples 3 and 4. Just because you have a variable, you can still simplify and solve it just like you did before. The geometric mean of a and b is defined as the square root of a times b if a and b are both positive, negative times the square root of ab if they're both negative. Now, if you remember geometry, you might remember that if x is the geometric mean of a and b, you will find that a over x equals x over b. This is the same idea, just written in a slightly different way. So keep that in mind. This is different than the arithmetic mean, which is the average. This is the square root of them multiplied together. Example 7. Find the geometric mean of -2 and -18. Because we have two negative numbers, you are going to use the second formula on the previous slide, negative times the square root of a and b. So, negative times the square root of negative 2 times negative 18, and your geometric mean is negative 6. Now you will notice that you cannot have a geometric mean of a number that's positive and another number that's negative, because you'll have an imaginary number after you take the square root. So, in this case, two negative numbers, this formula, if this was 2 and 18, the geometric mean would be a positive 6. The terms between two given terms of a geometric sequence are called geometric means of the given terms. So, if we have two terms, 1 and 16, and we put in 3 terms in between in a geometric sequence, those 3 terms are the geometric means, the 3 geometric means between 1 and 16. Now, you'll notice that these 5 terms form a sequence with a ratio of 2. Now, you might have also noticed that you could have 1, negative 2, 4, negative 8, and 16, where the ratio of the sequence is negative 2. Thus, these 3 numbers are also 3 geometric means in between 1 and 16. So you could possibly have 2 different geometric sequences with 1 and 16 and 3 numbers in between. However, if we are just looking for one geometric mean, it has to be positive here, because we remember that the geometric mean of 2 numbers, if they're both positive, is the square root of a and b. So this is reserved for a special case, because there's only one number we want to be a geometric mean of 2 numbers. Example 8. Insert 2 geometric means between 2 and negative 128. So if you were to write it out as a sequence, you would write it out like this. Now, the way you calculate this is you figure out you will have to have had t4 is t1 times r to the 4th minus 1. So you will notice that r cubed is going to be negative 128 divided by 2, or negative 64. If you plug in the fourth term, negative 128, the first term 2, and plug in 4 for n, you will see that this is the ratio. You will notice that you are applying 3 ratios from term 1 to term 4, so r cubed has to be negative 128 divided by 2. So if you use the formula, you won't go wrong. So if r cubed is negative 64, r is negative 4. Now, all we do is take r and apply it to the previous term. So 2 times negative 4 is negative 8. Negative 8 times negative 4 is 32. And those represent the 2 geometric means between 2 and negative 128. So you just write it out as if it were a geometric sequence. Try to figure out the ratio by using the terms you know and the number of terms in between them. Example 9. Insert 2 geometric means between 1/2 and 1/54. Try this last one yourself and check your answer after you resume the video. Alright, so there is our formula. T4 is T1 times R cubed. So let's plug in 1/54 for T4, 1/2 for T1 times R cubed. So R cubed, after multiplying both sides by 2, is 1/27. The cube root of 1/27 is 1/3. So that gives us the ratio. To find the 2 missing terms, the 2 geometric means, you take the 1/2 multiplied by the ratio, and you get 1/6 for the next term. 1/6 times 1/3 gets you 1/18 for the other geometric mean. Alright, in review, how do we find the formula for the nth term of a geometric sequence? You can calculate the first term t1 and the common ratio r. This is the formula you're going to want to remember. Tn equals t1 times r to the n minus 1 power. The nth term is equal to the first term times the ratio to the n minus 1 power. To find specific terms of a geometric sequence, use this formula above and plug in the appropriate value for n and solve for either t1 and or tn. That's it for 11.3. I don't think this material is super difficult if you follow along and think logically. If you have any questions, email me, ask me in class, or post a message on the Facebook page.